Welcome. In 2022, there are a lot of people with their own interpretations of how humanity and the universe came to be. And whenever you place these people together in one room, civilization will almost always come crumbling straight down. But even these people can agree that we humans are most definitely better than animals. I mean, we invented ice cream.
Ice cream?
Yes, ice cream. And we taught other humans how to make ice cream as well. We built planes and helicopters, jets and trains, just so that we can share ice cream with everyone around the globe and unify society. But in order to create a stove, or oven, or flavored mammalian colloid secretions from a female cow, measurements are needed. Measurements allow us to describe the facets of the world that we can observe in a quantifiable manner, but they only have value if someone else knows what you are referring to. Meaning, people would have to actually agree on something for a system of measurement to be useful. So, for a very long time, we did the opposite of agreeing. We disagreed. Everyone had their own arbitrary measurements. Different gallons for wine and beer, the distance between your inbred king's nose and his outstretched arm, that was declared 1 yard. The amount of grass your oxen could eat in one day, that was 1 acre. And high value British men wouldn't dare date any woman weighing over 1.4 million grams. Grams? No, not grams. Grains of wheat. It was a crazy time. The French Revolution brought the first true sense of unity. France went from having a 250,000 different units to standardization. The meter was declared 1/10 millionth of the equator. Countries saw the ingenuity or the advantages to having one system of measurement as opposed to hundreds, so they copied the metric system. Britain was the last to do so out of the major powers, and by the time they had accepted it, America was already established. The Americans kept the traditional values, the inches, the cups, the yards, of the imperial British measurement system for their citizens. However, the smart people, the engineers, the scientists, the NASA workers, the great thinkers, they all use the metric system. And today, we're going to learn a little bit more about that said system. So we have the 7 base quantities with which we can define the entire universe. Every other measurable action that can be formed or quantified is created by the interactions of all of these. They are length, mass, time, electric current, amount of substance, temperature, and light intensity. Now let's use a meter as an example that shows the setup of the SI system. I have 1 meter. Meters are great for describing certain distances. Let's say the length of a recreational field or the distance of a street. But the meter is terrible for saying the length of a country or the diameter of a screw. So let's place the meter as the focus of a line, and that meter will be multiplied by different powers of 10. These different powers are represented by different prefixes. On the right of the meter I have the deca, hecto and kilo, and on the left I have the deci, centi, and milli. These prefixes have universal meaning. For example, kilo means 1000. Milli means 1 over 1000 or 1000th. Hecto means 100. All of these prefixes have a universal meaning. When I convert the powers, we obtain different amounts of meters. And adjacent numbers will differ by 10 to the first power. So here's 1 meter, here's 10 meters, 100 meters, 0.1, 0.01, etc. To move to a bigger adjacent number, I multiply by 10, and to reach a smaller adjacent number, I divide by 10. You can see that clearly. If you want to move further than adjacent, of course you'll need to multiply with a larger multiple of 10. For example, to reach 100 meters from 0.1 meter, I need to multiply by 1,000, and I'll be jumping 1, 2, 3, 3 times 1,000. So where do the prefixes really come in, right? Instead of saying 1 meter times 10 to the power of 3, or saying 1,000 meters, you can just say that you have 1 kilometer. Instead of saying you have 1 over 1,000 or 0.001 millimeter, you can just say you have 1 millimeter. Instead of saying 100 meters, you can say you have 1 hectometer, right? It's just simpler. And because units of powers differ by 10, right? It's just 10 between all of them. Conversions are as easy as moving a decimal point. To convert from a smaller unit, so centimeters, to a bigger unit, meters, all you need to do is move the decimal point towards the left of your number. The number of spaces that you move will depend on how much of the smaller unit can fit in the bigger unit. So 100 centimeters can fit in 1 meter. So that means if I want to convert 138 centimeters to meters, I need to move this point here to the left 1, 2, 2 times. I move 2 spaces because 100 centimeters has 2 zeros. If I want to move 1000 millimeters to, let's say, 1 meter, right? That's the conversion. Well, I need to move to the left 3 times. Why? 1000 has 3 zeros, and you're going from a smaller unit to a bigger one, right? So this should be millimeter here. The M is in, but this is millimeters, right? So 1, 2, 3. So 179 millimeters is equal to 0.179 meters. Now, if you've been observant, you must realize that all I did there was divide, right? You divide the larger unit by the number of the smaller unit. So let's say 100 centimeters to 1 meter, you divide by 100 centimeters, or by 100 in that case, right? To convert from a bigger number to a smaller number, move a decimal point to the right. I have 56 kilometers, right? I want to convert 56 kilometers to decimeters. Well, 1 kilometer equals 10,000 decimeters. So if I have 56 kilometers, I need to multiply by 10,000, and I'll move my point 4 times. 1, 2, 3, 4. My point comes right here. So 56 kilometers is 560,000 decimeters. The system of placing prefixes in front of base unit is the entire basis of the metric system. So for other measurements, other quantities, for example mass, you have the same style. So the gram is the base unit, but the gram will be covered or will have other prefixes in front of them. So decigram, centigram, milligram, the same prefixes. You use it across the board for all the other quantities, all the other stuff that you can measure, right? For electric current, you measure in amperes, and you have the same prefixes, but they might even have other ones. For example, electrical companies may use a larger prefix, such as mega amperes, because they are dishing out electricity to the entire country, right? So mega means a million, right? So that's a million. Mega is a million. And that's what it's used for a company as large as an electrical company. No, don't bang your head over all the prefixes that you have to remember. Everyday life will not require you to use all. For length, for distance, the most common stuff are the millimeter, centimeter, meter, and kilometer, right? In the scientific community, you'll see the nanometer and the micrometer more commonly, right? For mass measurement, it's really just the milligram, the gram, and the kilogram. For time, you have seconds and you have milliseconds. Whatever the case, the fundamental units of measurement can easily be converted or manipulated for whenever you need to build a 27-kilometer particle accelerator or an ice cream maker, right? But the final question, how can these 7 quantities explain our universe, you ask, while you scratch your head? How can just 7 work? Well, we'll find out next time.